Imagine driving on a highway reinforced not with steel or concrete, but with bamboo. It sounds unbelievable, yet in Indonesia, it's already happening. The Semarang-Demak Expressway has made history as the world's first major road project to use over 10 million bamboo poles to stabilize weak coastal soil. Faced with land so fragile it borders the Java Sea, engineers abandoned conventional methods and turned to bamboo, renewable, resilient, and surprisingly strong. More than 1,500 skilled workers helped lay an enormous bamboo mat beneath the roadway, transforming terrain once considered nearly impossible to build on. In this video, join Extreme Discovery as we uncover how an ancient material is solving modern engineering challenges and why bamboo may shape the future of infrastructure. For decades, the northern coast of Java Island has been battered by frequent flooding. Every year, dozens of floods send tens of millions of cubic meters of seawater rushing inland, submerging downstream areas within hours. The Semarang-Demak project was conceived not just as a highway, but as a protective sea barrier, designed to shield thousands of homes from recurring flood disasters while restoring vital transportation links. The expressway stretches 26.95 kilometers in total and is divided into two sections, Semarang-Sayang, 10.64 kilometers, and Sayang-Demak, 16.31 kilometers. The Sayang-Demak section opened to traffic in February 2023, while the Semarang-Sayang segment, where the innovative bamboo mat system is being deployed, remains under construction and is scheduled for completion by early 2027. The bamboo mat system stands out as the most cost-effective, durable, and environmentally friendly solution. As a natural material, bamboo produces no pollution, can be sourced locally, and does not disrupt marine ecosystems or shipping activity. Indonesia is uniquely suited to this approach, with 162 bamboo species out of roughly 1,390 worldwide, ensuring an abundant and sustainable supply capable of supporting large-scale infrastructure for decades. Before installation, every bamboo pole undergoes strict quality inspections to guarantee mechanical strength and long-term performance in seawater conditions. Two primary tests are used, a transverse tension test to assess torsional and tensile strength, and a perpendicular bending test to evaluate elasticity and recovery after deformation. Only poles with a minimum diameter of 10 centimeters, a straight length of at least 8 meters, and an age of 3 years or more meet the construction standards. Once approved, the bamboo poles are transported to the site and transformed into the foundation of a highway built over the sea. The poles are driven vertically into the soft seabed like stakes. Every 7 poles are tightly bound together to form a single bamboo pile. These piles are installed at roughly 1-meter intervals. Bamboo rafts are then assembled by tying poles together and laying them across the piles. At both ends, the piles are securely fastened to the rafts according to the original design. Over time, the bamboo mats gradually sink and integrate with the seabed, reinforcing the underwater structure much like an artificial reef. The final stage involves laying geotextile fabric across the bamboo foundation. This layer acts as a separation and load distribution membrane, preventing sand from filtering into the gaps between bamboo mats while stabilizing the surface for the layers above. Spread evenly across the full 150-meter width and continuously connected between sections, the fabric creates a uniform, durable, technical cushion.
After the geotextile fabric is fully secured, the project enters one of its most visually dramatic stages. Off the coast of Java, massive dredging vessels move into position to create the expressway's foundation surface. High-capacity ships, known as trailing suction hopper dredgers, lower powerful suction pipes beneath their hulls. The sand is stored in onboard hoppers and then pumped through special conduits, evenly spraying it across the bamboo raft system over a width exceeding 150 meters. This operation covers a foundation length of nearly 6 kilometers, forming the base of the highway replace section by section. The process is repeated methodically, one layer of bamboo followed by one layer of sand until a total of 17 alternating layers are completed. The result is a foundation that is both exceptionally load-bearing and flexible enough to adapt to the harsh, shifting conditions of the marine environment. To accelerate the stabilization of the soft seabed, engineers install vertical drains, narrow drainage strips inserted deep into the soil. These drains act like escape channels, allowing trapped pore water to rise quickly to the surface instead of remaining locked inside the soil. As the sand layers apply downward pressure, water is forced upward through the drains and released. This dramatically speeds up soil consolidation, shortening settlement time by several times and allowing the project to reach the required stability far sooner than conventional methods. Once the foundation stabilizes, construction transitions into a process similar to that of a standard expressway. Multiple structural layers are built, each with a specific role. The subgrade, normally compacted natural soil, is replaced here by the bamboo sand composite, acting as the primary load-bearing layer. Above it lies the subbase, made of crushed stone to enhance strength and prevent upward soil movement. The base course, composed of granular material or bituminous mixtures, distributes vehicle loads evenly. Finally, the surface course, made from bitumen and mineral aggregates, provides a smooth, durable, and wear-resistant roadway for daily traffic. From highways stretching across the Java Sea to towering skyscrapers in Hong Kong, bamboo's journey continues, evolving from a humble natural material into a critical element of modern construction. Hong Kong, a city of more than 9,000 skyscrapers, has nearly twice as many high-rise buildings as New York and 3 times as many as Shanghai. Yet among this forest of steel and concrete, bamboo scaffolding remains a defining feature of the skyline. Unlike most of the world where metal scaffolding dominates, Hong Kong still relies on traditional bamboo scaffolding, a craft refined over centuries. Before bamboo reaches the construction site, each pole undergoes careful selection. Only bamboo aged 3 to 5 years and air-dried for at least 3 months is approved, ensuring maximum strength and flexibility. Each pole can be reused up to 3 times before it begins to lose its structural integrity. Once approved, the bamboo poles are transported to construction sites and assembled into towering frameworks that wrap around buildings from ground level to the very top. The scaffolding forms a dense lattice in the sky, lightweight yet remarkably strong when assembled with precision. 2 main types of bamboo are used: thicker poles for load-bearing sections and slimmer, lighter poles for frame connections. All joints are tied by hand using nylon knots, a highly skilled technique that takes years to master. Bamboo's natural flexibility allows the scaffolding to adapt to balconies, curved facades, and complex architectural forms that rigid metal systems struggle to handle. While scaffolders once climbed dozens of stories with little protection, modern regulations now require full safety gear, including harnesses, helmets, gloves, and non-slip footwear. Despite its strength, bamboo is never perfectly uniform, which makes this construction method extremely craftsmanship dependent. Every knot is tied by hand, and even a small mistake can compromise the entire structure. As skilled practitioners become fewer, bamboo scaffolding has disappeared in many parts of the world. In Hong Kong, however, it endures, celebrated not just as a practical solution, but as a living symbol of sustainability, craftsmanship, and Asian construction heritage.
Today, bamboo is widely recognized as one of the green materials of the 21st century, valued for its remarkable strength and rapid renewability. With a tensile strength that can surpass steel, bamboo is capable of carrying heavy loads while remaining lightweight, flexible, and easy to shape. By contrast, steel production depends on energy-intensive processes that burn vast amounts of fossil fuels. Many countries lack the resources or infrastructure to support large-scale steel manufacturing, driving up costs and environmental damage. Bamboo offers a powerful alternative. It can be grown locally, harvested at low cost, and replenished quickly. In tropical regions, bamboo matures in just a few years, requires minimal care, and regenerates naturally after cutting. For these reasons, bamboo is more than a construction material. It represents a new direction for sustainable architecture, where strength, efficiency, and environmental responsibility coexist. Other applications. Beyond construction, bamboo has become an eco-friendly substitute for plastics in everyday life. It is now widely used to produce items such as straws, chopsticks, toothbrushes, cups, spoons, baskets, and decorative goods. Thanks to its strong longitudinal fiber structure, light weight, and natural resistance to moisture, bamboo can effectively replace plastic, one of the world's most damaging pollutants. Each bamboo straw or pair of chopsticks may seem insignificant on its own, yet collectively they help reduce single-use plastic waste and encourage a greener lifestyle.
The manufacturing process is simple and energy efficient. Bamboo is cut, boiled, dried, polished, and then treated using natural antibacterial methods such as steaming or bamboo vinegar soaking. The final products are safe for human use and fully biodegradable after disposal. In many regions, small bamboo workshops have evolved into sustainable production chains. Bamboo waste is also put to use. Some is converted into bamboo charcoal, prized for its odor-absorbing qualities and commonly used for air purification, deodorizing cars and rooms, and even water filtration. During charcoal production, bamboo vinegar is generated as a byproduct, finding applications in medicine and as a natural termite repellent. Nearly every part of the plant is utilized, forming a closed-loop, low-waste system. For centuries, bamboo was seen as a humble material, associated with village houses, simple tools, and rural bridges. Yet through human ingenuity, its potential has been completely reimagined. What once stood as a slender stalk now forms the foundations of highways built over the sea and scaffolding that supports some of the world's tallest skyscrapers. The true miracle of bamboo lies not only in its strength, but in the mindset behind its use, the belief that simplicity can achieve the extraordinary. In an era dominated by advanced alloys and heavy machinery, bamboo reminds us that innovation does not always require inventing something new. Sometimes it begins by seeing the familiar with fresh eyes. With its flexibility, resilience, and sustainability, bamboo stands at the crossroads of tradition and modernity. It is no longer just a symbol of cultural heritage, but a material of the future, one that embodies innovation, environmental balance, and respect for nature in an increasingly industrial world.